All right. In this video, we're going over an Edgenuity Exploring Real Numbers quiz. Now, I've noticed that quite a few students are struggling. Hopefully, you're checking your emails, looking for the notes, looking for the videos. Hopefully, you're asking your teachers while you're at school. And if you're struggling at home, hopefully you're asking your parents. Make sure you're reaching out. When you get locked out, make sure and check your email. All right, first question we're going to look over today, which is 0.54 with a bar above it, which means it repeats 54 hundredths, and it repeats 545454, converted to a simplified fraction. As you can see, this student picked 54 hundredths. The problem with this is a terminating decimal. So this would just be 54 hundredths. The 54 doesn't go on forever. Same as this top one. If I divide 27 by 50, I'm going to get 54 hundredths, and again it stops. So, but this, with the bar above it, it means, sorry, that's bad. But with the bar above it, it means it goes on forever. Now, as you can see, there's this answer, but we're going to talk about the bottom one first. 54 divided by 99 is, in fact, you divide 54 by 99. How do you turn any fraction into a decimal? Divide the numerator by the denominator, and you're going to 0, 0, and it's going to be 5, 4, 5, 4. It's going to go on forever. If we actually divided this out, me personally, I'd be using a calculator on these problems. You don't get to use it on the 5th grade test, but you do get to use the calculator on the 8th grade test. Don't be afraid to check your work with the calculator, and when you're doing work like this, I would definitely use the calculator. So, Mr. Hewlett, they have a check here. Why isn't this one the answer? Well, keyword right here, simplified. This is not simplified, therefore it can't be the answer. 6 divided by 11 gives you 0.545454. It goes on forever, so we put the bar above it. But this one is, in fact, simplified. This is simplified, so that is the answer. So again, how do you turn a fraction into a decimal? Divide the numerator by the denominator. Check it with your calculator, or just do it with your calculator. The reason 6 over 11 is your answer, as opposed to 54 over 99, which both give you 0.54 with the bar above it. This one right here is simplified, so that's your answer. Next problem that a lot of people are missing. The repeating decimal, 0.27 with a bar above it, 0.27, 27, 27, so on and so forth, is converted to the fraction 3 over something. What is the value of x in the fraction? Now this one is not too difficult because, again, this one I would definitely use your calculator to check your work. And I'm going to teach you a little trick. Anything, now this student put over 9, anything over, if 9 is the denominator, it's just going to be that numerator repeats. If I had 4 ninths, it would be 4/10 and it repeats. If it's 5 ninths, it would be 5/10 and it repeats. So obviously that's not the answer because we have 0.272727. So why is it 11? If I divided 3 by 11, I would in fact get 0.27, and that pattern would go on forever. This is one you should be able to do by hand, dividing the paper and pencil, divide the numerator by the denominator. But again, don't be afraid to check your work with the calculator. What value of x will make the equation true? So, if we look at this, the square root of 5 times the square root of 5. The answer is 5. Now, why is that? Now, first of all, we have to know what square roots are, square roots of a number. So I'm going to start with an easy one. Square root of 4 is 2. All right, so why is it 2? So this one is called a perfect square, and the reason it's 2 is because I'm looking for 2 exact numbers that I can multiply together to get to 4. And 2 times 2, or 2 squared, is actually 4. Another example would be 16. The square root of 16 is 4. Why? I'm looking for, again, one number, it's exact same, oneself, that I can multiply together to get to 16, and 4 times 4 is 16. So, the square root, let's clear this out, square root of 5 is going to be an irrational number, which means if I do the square root of 5, I'm going to get I have to use a calculator on this. I can show you a trick in class how to get really close to the actual value, but let me erase that. It's actually where we have room, square root of 5. I'm doing squiggly lines. Why? Because that means approximately. I can get approximately the same value, but since it's irrational, I can't write enough of the numbers in place value. Eventually I run out of room or time, so this is my answer for the square root of 5. It's approximately 2.23606, but again, it goes on forever because it's irrational. Again, irrational, you can't write in the form of a over b. It will look like a number with a decimal that goes on forever with no pattern. All right, so why am I bringing this up? If I were to multiply, if I were to grab my calculator and multiply these numbers, and I'm going to do that right now, 2.23606 times 2.23606, I get this, 4.99964, so on and so forth. As you can see, this number is really close to 5. Well, Mr. Hewlett, why didn't you get 5? Because I didn't use all the numbers that were the actual value of the square root of 5. If I'd used a calculator with square roots, if I just did the square root of 5 times the square root of 5, I would have got 5. Another way of thinking this is the square root of 5, I'm multiplying it by itself, which is squared, which ultimately means it's going to be 5 times 5, which would be the square root of 25, and as we know, the square root of 25 is 5, and that's why that's the answer. All right, next problem. Which expression represents rational numbers? Check all that apply. And again, a rational number is a number that can be written in the form of a over b. It's a number that doesn't have a decimal that goes on forever with no pattern. That's called irrational. Again, irrational is a number that looks like it has a decimal, goes on forever with no pattern. If it goes on forever with a pattern, such as 1/3, that would be 0.333333. That is rational because I can write it in the form of a over b. It is rational because though it has a decimal, it goes on forever, it definitely has a pattern. Okay, so this first one, why isn't it rational? Now, square roots are easy. So square roots are easy in the fact that, let me erase this. Square roots are easy in the fact that if it's a perfect square, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and so on and so forth. If it's not a perfect square, it's always going to be irrational. The square root of 5, as we just went over, is irrational. The square root of 6 is irrational, meaning it's going to have a decimal, it's going to go on forever with no pattern. And so as you can see from here, we have the square root of 6. It is irrational, and if I add a rational to an irrational number, it's always going to be irrational. You can check that on the calculator. All right. Square root of 64, we know, is 8. Is 6 over 11 rational? Let me check it on the calculator. It's 0.54. It repeats. Though it has a decimal that goes on forever, I can write it in the form of a over b, so it is rational. So if I add it two rational numbers, it stays rational. All right. Erase this. Why is this irrational? Square root of 36 is easy. Square root of 36 is 6. Square root of 16 is 4. Square root of 25 is 5. But square root of 21 is not a perfect square, so it is irrational. It is irrational, so that's why this is definitely not a rational number. All right, what about the next one? Square root of 16 is 4. What's the square root of 169? Well, if you didn't know that, you could use your calculator, but square root of 169 is 13, because 13 times 13 is 169. So this definitely is rational. Now this one, square root of 49 is 7. And though this has a decimal that goes on forever, it has a pattern, so it's rational. So this is rational. Square root of 25 is 5, but square root of 44 is not a perfect square. Why? Because square root of 36 is 6. Square root of 49 is 7. This is in between, so it's an imperfect square. So, meaning the sides will be made up of irrational numbers. So this is definitely not rational. So hopefully that has helped. Let's look at another problem. Which irrational number can be added to get pi, to get a sum that is rational? Now this student picked this, and I definitely understand why you would. Now, if we were multiplying, that would be something different. But on this, let's look at this. Pi and sum means, okay, I'm adding something, and I need a rational number. Rational number means I can write it in the form of a over b. Now, if we look at the previous examples, we said that if I add a rational to an irrational number, it's going to stay irrational. Why am I bringing this up? I need to add something to pi which is irrational to get a rational number. Now the trick is, maybe cutting a little bit of a lie, this is the answer why. Because if I added a number, pi, and its opposite, the opposite of a number is, meaning it's the opposite side of 0 on the number line. So like if I had 2, the opposite is negative 2, because it's on the opposite side of the number line. The opposite of negative 2 is 2, because it's on the opposite side of the number line from 0. If I added these numbers together, 2 plus negative 2 is 0, or negative 2 plus 2 is 0. If I add a number and its opposite, I'm always going to get 0. So pi plus negative pi is going to give you 0. It's like having pi, and then you're subtracting, you're going to take it away, and so you're left with 0 pi. And 0 is a whole number. It is an integer. It can be written in the form of a over b, and just whatever number you would want to put on the bottom. We'll just write a variable. You can write it in the form of a over b, so it is rational. So that's why this is the answer. All right, which is the correct classification of the square root of 18? Just want to hit on this one more time. It's not a perfect square. It's in between square root of 16, which is 4, and the square root of 25, which is 5. So these are perfect squares. 18, square root of 18 is not. That means it's irrational. Means it goes on forever with no pattern, and that's why this is the answer for square root of 18. Excuse me. Which irrational number can be multiplied by negative square root of 41 to get a product that equals 1? All right, so as you can see, this is not a perfect square. Square root of 36 is 6. Square root of 49 is 7. But let's go over something really fast. Square root of 36 is 6. But what's the square root of 36 times negative 1? So if I have that negative side outside of it, square root of 36 is 6. But then you multiply by negative 1, so your answer here would be negative 6. Okay? So as I look at the square root of 41, and then I have a negative sign outside of that, I know it's going to be slightly greater than 6 if it were positive. So the square root of 41 is approximately, it's an irrational number, so I can't get exactly there. Oops, sorry. Square root of 41 is approximately, all right, so square root of 41 is approximately 6.40312, yada, yada, yada. Goes on forever. And then I'm multiplying by negative 1, so that gives me that. So which irrational number can be multiplied by the square root of 41 times negative 1 to get a product that equals 1? Why is this the answer? Well, let me explain. Let me erase this. This can't be the answer. Why? Because this is the same number. So it would be like multiplying these two numbers together. And a negative times a negative does give you a positive, but forget the decimal. 6 times 6 is 36. And so that's definitely not close to 1. So that could not be the answer. So let's look. Why is this one the answer? Well, let me show you another example that might maybe make a little more sense. What can I multiply 6 by? I'm going to get rid of that. I shouldn't use an X for multiplication. What can I multiply 6 by to get 1? Well, the answer is 1/6. I can multiply it by its reciprocal, because I can turn 6 into a fraction by putting 1 underneath it, because 6 divided by 1 is 6. And its reciprocal, which means ultimately to flip it, is 1/6. And 6 times 1 is 6, and 1 times 6 is 6, and 6 divided by 6 is 1. So looking at that example, we can understand why this would be the answer, because square root of 41 negative is negative 6.403. I'm going to stop there just for time's sake, and then multiply it by negative 1 over 6.403. They cancel each other out, and a negative times a negative is a positive, and so your answer is 1. And that's why that's the answer. All right, well, that concludes the exploring real number quiz. Hopefully these have made sense. I'm going to quickly go over this again. Simplified fraction, this is the answer right here. Okay, this is a reading problem. Make sure you simplified your fraction. Please use calculators. Mr. Hewlett, how do you turn a fraction into a decimal? Divide the numerator by the denominator. Check your work with the calculator, or just use the calculator. All right, this one. Convert it to a fraction. Don't be afraid to, again, check your work with the calculator. On this problem, square root of 5 times square root of 5 ultimately is the same thing as square root of 5 squared, which means it's square root of 5 times 5, which is 25, and the square root of 25 is 5. On this one, we talked about rational numbers. You can write them in the form of A over B. If I'm adding numbers, unless it's by its opposite, I can't add a rational and an irrational, or irrational and an irrational, and get a rational number. Unless I'm adding it by its opposite, which will give me 0. And 0 is rational because it's a whole number. It's an integer. You can write it in the form of A over B. Again, we talked about what irrational is. You cannot write it in the form of A over B. It has a decimal. It goes on forever with no pattern. And then we talked about which irrational number can be multiplied by negative square root of 41 to get a product that equals 1. And we talked about multiplying it by its reciprocal, which if you multiply a number by its reciprocal, it will equal 1. All right, well, I hope this has helped. Make sure, again, during the daytime, you're asking your teacher for help if they have time and are able. At home, make sure you're reaching out to your parents and email the teachers. When you get locked out, email Mr. V, email myself. I'm locked out. I need some help. Send me something so I can understand whatever topic you're struggling with. So have a great day, and if you need anything, you can email me, jhewlett@leisd.ws. Thanks. Bye.